Okay, let's look at graphing two cycles of a transformed secant function. And you notice I've got my graph paper set up here, so we'll work with some graph paper. And we've got our function listed. F of x equals 2 minus secant of the argument or angle 3 pi x plus 2 pi. Okay, so the first thing I'm going to do is I'm going to rewrite this in a way that seems to make more sense for me, especially when I'm thinking transformations. So this is the same thing as negative secant of that argument plus 2. So because this 2 is positive, it's the same thing as being added out here, okay? And so that's helpful because when you see it like this, you know it means shift up 2. Let me just copy this argument back down now. All right, so what we need is we need to address the y transformations here. And before we do that, we need to understand the shape of the secant function. So let's start with the shape of the secant function first. So if I'm thinking secant, it's the reciprocal of cosine, and the cosine function from 0 to 2 pi, at 0, it starts up here at 1. Sorry. 1 is written vertically. Starts up here at 1. And then at 2 pi, over here, it's back at 1. In the middle, it's at negative 1. And at the quarter points, it's at 0. So this is our cosine function. So that's y equals cosine of x, okay? What we are interested in is the secant function, which is the reciprocal. So every place that cosine is 0, secant is undefined because the reciprocal of 0 is undefined. You can't divide by 0. So cosine is 0 at those two quarter points, so secant has asymptotes. Then, where cosine is 1, secant is 1 also because the reciprocal of 1 is 1. And when cosine is negative 1, down here at the bottom, the reciprocal of negative 1 is also negative 1. So those 3 points are common to the cosine and secant graphs. But as cosine gets smaller and closer to 0, secant grows and gets infinitely large. And so we see that behavior exhibited near each of these asymptotes, okay? So what's left there in red is the secant of x function. So that's our shape there. So this is our sort of parent function graph with the asymptotes shown. So we've got the shape done. Now we need to do the y transformation. So the first y transformation is multiplied by negative 1. Sorry, let me list this. This y value is negative 1. This one's positive 1. Of course, this is 0. So I'm going to multiply the y values by negative 1. So what that's going to do to my graph is it's going to flip it over. So basically, you're going to have the start of your graph is going to be at negative 1. The middle is at 0. The top is at positive 1. But now, instead of starting up here at positive 1, that's going to start down here at negative 1. And let's draw on our asymptotes at the quarter points. The end is going to be at the negative 1 also. The top is going to be at positive 1. And now this side's going to go down and approach the asymptotes. These are going to go up, and this is going to go down. So that's our new shape after you multiply the y's by negative 1. And then the second y transformation is to add 2 to the y's. So what that's going to do is change this 1 to a 3, the 0 to a 2, the negative 1 to a 1. Okay, so now the bottom of the graph occurs at 1, the middle occurs at 2, and the top occurs at 3. And of course the y-axis, or the x-axis now is down here, okay? But now this is the bottom, so begins and ends at 1. In the middle is at 3, and then in the quarters are the asymptotes again. And so you end up with this sort of thing. So it's been shifted up by 2 from where it was over here, okay? So this guy right here is the shape that we're going to deal with, and we just have to determine where does it start. In other words, what x value is it going to start at right here, and what x value is it going to end at over here. And then we can determine things like the period, how long that cycle is. So this will be one cycle, okay? But we have to figure out where it starts and ends. So the secant function starts and ends at 0 and 2 pi. The secant of x function starts and ends at 0 and 2 pi. So now we have to see what happens when we look at this secant of all this mess, that argument. So the function's x values are going to begin, the cycle is going to begin whenever that 3 pi x plus 2 pi equals 0, and it will end when that equals 2 pi. And so now we can solve each of these for x to find out where x starts and ends, what x value is on the x-axis. So here we're going to subtract 2 pi, so we get 3 pi x equals negative 2 pi. Then we're going to divide both sides by 3 pi, and the pi's cancel, so that means x starts, the cycle starts whenever x is negative 2/3. So let's see where it ends. So I'll subtract my 2 pi, so I get 3 pi x equals 0. Divide by 3 pi and I get 0. So my cycle starts at negative 2/3 and ends at 0. So now I need to put this picture within these x values. So let's look at how to do that. Okay, so let's set up our plane here. I know that my important y values are 1, 2, and 3. So I'm going to put my x-axis kind of low here. This is 0, of course. And then let's say that this is 1, this is 2, this is 3. Okay? So those are my important y values. Now my important x values are negative 2/3 and 0. And so I need to decide on the intervals I want to use on my x-axis. I could use 1/3, but I'm going to kind of spread them out. I'll use 2 grid marks for every 1/3. So I'll call this a third, which means this is 2/3, and so on. 3/3, 4/3, 5/3, etc. And on the left side, I've got negative 1/3, and then 2 grid marks over, I've got negative 2/3, and that's where my graph's going to start. And it's going to end at x equals 0. So I need to squeeze this picture into the box in between negative 2/3 and, not positive 2/3, but negative 2/3 and 0. Okay? So let's get busy. What's the pattern for this graph? Well, inside the yellow box up here, the graph begins and ends at 1, and in the middle is at 3. So the beginning is on the yellow line. It begins at y equals 1, ends at y equals 1, and in the middle is up here at 3. Okay? Then, at the halfway points, the quarters, I have asymptotes. So then I look right here, and I've got an asymptote for this particular secant function. And then I have to draw in my behavior of this function. So this guy is going to go down, these are going to go up, and this one's going to come in and down. So that's the same shape that we had before, but now the x values are correct as well. And while we're here, we can go ahead and state that this cycle length, this period, well, it's pretty easy. I'm going from negative 2/3 to 0, so my period is the length of 2/3. That's how long the cycle is. Now, the directions tell me to graph 2 cycles. So all I need to do is draw another copy of this cycle to the right or to the left. And since I've got more room on the right, that's what I will do. So I need to, because my period is 2/3, I need to measure another 2/3 from 0. So my next period is going to end my next cycle is going to end at 2/3. So it's going to be between 0 and 2/3. Then I repeat the same process. It starts at 1, ends at 1, in the middle is at 3, and at the quarters I have asymptotes. Then I can draw in the shape of the function going down, and then up, and then down. Okay? And now I have 2 complete cycles of my secant function. Alright? So same idea as I've talked about in all my other videos as far as graphing with the x transformations and the y transformations. The key is, when you want to graph these functions, you better know what their shapes are. If you don't know what secant looks like, you're dead in the water here because none of the transformations matter. So make sure you know all of your trig function shapes.